Hello everyone, this is Shauna coming to you with this week's tutor check-in for your geometry. Just here to give you a brief overview of the lessons that you're going to be covering this week. The first lesson that you're going to cover is a lesson on convex polygons. And we saw last week, we talked a little bit about polygons, and we got into some of the shapes of polygons, but this week we're going to talk about convex polygons. These are the ones that are probably more familiar to you. They're the closed ones, and they have no gaps and no openings. They're all closed figures, and all of the angles, all of the individual angles in a convex polygon are less than 180 degrees. So there's no strange angles. One thing that I wanted to draw your attention to was this slide here where we name polygons. We name polygons by the number of sides they have. A three-sided polygon, a triangle. And you probably never thought of a triangle as a polygon, but it is. A four-sided polygon is a quadrilateral, and not all quadrilaterals are what we're used to. Normally, if I tell you what is a four-sided figure, the first responses that come to mind are usually a square or a rectangle, and those are quadrilaterals, but there are several other quadrilaterals that you're going to be learning about. Pentagon, five-sided figure. Hexagon, six-sided figure. Notice the spelling, the difference in spelling between the hexagon and the heptagon. It's only a couple of letters different. Hexagon, 6. Heptagon, 7. Octagon, 8, like octopus. Nonagon, 9. Decagon, think of decades, that's 10. And then 12 is a dodecagon. After 12, we just call it an n-gon. And what that means is that whatever number of sides it has, maybe 15, you'll see 15 with the suffix gon. So it'll be a 15-gon or a 13-gon or a 25-gon. That's how that is. We don't have special names, too many for gons after 10. And then we have some of the same vocabulary that you were seeing last week with triangles, we're now applying to polygons. So we have equiangular polygons. The angles are all the same. An equilateral polygon where all the sides measure the same, and regular polygons where both of the following are true. You have the same sides, so all of the sides are the same length, and all of the angles are the same size. The rest of the terminology here in this section is pretty straightforward. You'll be able to study that more in the slides as you go along. I'm also going to share at this time the next section she'll be working on, so bear with me for just a moment here. We're going to look at a whole section devoted to triangles, and we have actually large amounts of courses that deal with triangles, but this lesson in 3.1 specifically focuses on congruent triangles. So let me share that with you at this time. So here we are looking at, this is section 3.1, okay? So we have a lot of words that begin with C in these coming up lessons, so don't confuse them all. We have congruent. We have corresponding. We had convex in the other lesson. There's some other C words, but congruent just means that angles or sides or polygons or figures are the same size and shape. That's what that means. You can put one right on top of the other and they'll be the same size and shape. They'll be exactly the same. Corresponding angles we talked about last week. Those are angles that are in the same relative position to each other, and corresponding sides are similar. They're in the same position as corresponding angles. So you have two figures, you compare them, those sides will be in the same position. And there are examples on the slides of this. So now one of the things I wanted to draw your attention to is a little bit of a notation. Sometimes students have difficulty with this. Here you see hash marks on the sides and you see arcs on the angles. Notice that there's a different number of arcs on each angle. Why is that? This is a shorthand way of showing you that angles are congruent. So if you look at angle A, that has one arc on it. Look for the angle in this other picture on the right that has one arc on it. That's angle D. So angle A and angle D are congruent, they're equal. Angle B has two arcs on it. The angle that has two arcs on it is angle E. Angle B and angle E are congruent. Angle C and angle F are congruent. So if you have angles, typically you make arcs on the angles to show that they're the same. If you have sides, you make a little tick mark. So once again, you match the number of tick marks on one side to the number of tick marks on the other. So the side AB is congruent to side DE, right here. The side BC is congruent to side EF. And the side AC is congruent to DF. Okay, so pay attention to that. Another thing in this lesson that pay attention to is different ways to prove that triangles are congruent. So obviously, triangles have three sides and three angles, and we have several ways to prove actually that triangles are congruent. Side congruence is pretty straightforward. You show that all of the sides in one triangle are congruent to all of the sides in the other triangle. But we have two other ways. We have more than that, but we have two other ways in this lesson that we're going to focus on. One is side angle side congruence. And here, notice that the order in which the letters are written is a clue to what this theorem actually says. There's a side, there's an angle in the middle, and there's another side. And that's exactly how this works. If two sides and the included angle of one triangle. The included angle is the angle between the two sides that you're showing to be equal to each other. So the two congruent pairs of sides should be hugging an angle that you're trying to show is congruent. It's between the two sides, okay? That's side angle side congruence. Now, we have angle side angle congruence, and that is a little bit different. Here, the side is in the middle. So we have two angles hugging a side, if you will, or two angles bracing the same side. So there's a side between two angles. That's the same thing, okay? So we can show triangles are congruent with angle, with side angle side, or with side, side, side. And that's what lesson 3.1 is going to focus on. We can also have angle side congruence. So this is two angles and the side that's across from them, one of the sides that's across from them. This is not angle side angle because the angle doesn't brace the same side that you're trying to show is congruent. And that's how you tell. It's angle side. Okay? So you're going to be looking at those congruence postulates in 3.1. And finally, we have one more lesson which I'm going to bring up here and show you. Let me see if I have it open. 3.2. There it comes. Let's make sure you can see it. Yeah, so I'm gonna share the screen and wait for the Chrome extension. It's not going to show me, so let me see if it will show me in here. Let me see if I can share the screen by the setting and my files will course with me. We shall see, ladies and gentlemen. 3.2. There it comes. Let me just share the screen at this time so that you can see what I'm looking at. So we have corresponding parts of congruent triangles. Remember, corresponding parts are parts that are in the same relative position to each other. This section can be a little bit tricky in terms of writing the proof. So we go through, we kind of give you an overview of what we did in 3.1. We show that we proved triangles congruent. We give you that. And then we talk about the conclusions of proof with corresponding parts of congruent triangles. And so we get into what we call formal proof, which is this two-column proof that you see here, okay? And so you have to know your proofs, know your postulates and know how to prove triangles are congruent. You can have possibly more than one right answer to this. So if you have questions when you're proving these, be sure and ask us, okay? We have lots of examples here for you. We also talk about right triangles in this lecture. We're not giving you the Pythagorean Theorem necessarily, although that is referenced here, but we're showing how to show that specifically right triangles are congruent. And remember, right triangles have a 90-degree angle in them. So we have what we call the hypotenuse leg congruence, and we have the leg congruence. So you'll see that when you go through, and then we have your friend, the Pythagorean Theorem. So that should be very familiar to you. But just in case you may have forgotten, On a right triangle, it's a right triangle because of this square corner, and that means that angle is 90 degrees. These straight sides that are not slanted are the legs, and this long slanted side is the hypotenuse. The hypotenuse is always directly opposite the 90-degree angle, no matter where that 90-degree angle occurs. The hypotenuse is always the longest side in the triangle. So that's relatively straightforward and should be relatively familiar to you. I did a previous video that should be up soon, if it's not up already, about the comments that are on your homework assignment from the last homework. So if you got comments on your homework and you don't understand how to fix them, or if you got a turned in comment like you were missing your name or the section number, something like that, I did make a video with some homework hints that's separate from this one. Go ahead and watch this video for an overview of this week, and I hope you're doing well. I hope you're healthy, and I will chat with you again very soon. Take care, everyone, and I will talk to you later. Bye for now.